Hello students, welcome to the physics class. Today we will be solving NEET 2016 question paper. As you know, each question carries 4 marks and in total there are 45 questions. So how many marks will be there? 180 marks will be there. So again today I will giving you some idea and the solving part will be done by yourself, and I will also give you the answer which one is the correct option. So let us start one by one. Let us see number 1 first. It says that from a disk of radius r and mass m, a circular hole of diameter r whose rim passes through the center is cut. What is the moment of inertia of the remaining part of the disk about a perpendicular axis passing through the center? So this is a question came from system of rotational bodies of class 11. Let me show you the diagram of this one. So first I have a circle which is of radius r, right, and then I have taken another circle whose diameter from here to here is r by 2. You have to calculate the moment of inertia of the remaining portion of the circle. So for this one the answer comes out to be, if you solve, it is number 2, 13 mr square by 32. So try to solve this one and find its answer. This is the correct answer. So now let us move to the next question, that is question number 2. Question number 2, it says that a square loop ABCD carrying current I is placed near and coplanar with a long straight conductor XY carrying a current I. The net force on the loop will be, as we know, this is a question from the magnetic effects of current where the force between the two parallel wires that can be calculated. So along AB, you know, the direction of current is given. So what will be its force, you have to calculate. So this is the concept which you can use, force due to parallel wires. Okay, and the option for this one, the correct answer will be the first one, 2 mu naught I into small I, which is the current passing through A, B, C, D. Okay, the direction of current is also given, the loop you can choose in that way, divided by 3 pi. This is the correct answer. So number 1 is the correct answer for this question. Yeah. Now let us move to the next question, that is question number 3. Number 3, the magnetic susceptibility is negative for which type of material? Negative, it's negative only for diamagnetic material only. Paramagnetic, paramagnetic and ferromagnetic materials, they have what? Positive susceptibility. So the correct answer is number 1, diamagnetic materials only. This is a direct question from the chapter magnetism. Okay. So option 1 is your correct answer. Now let us move to the next question, that is question number 4. A siren emitting a sound of frequency 800 Hz moves away from an observer towards a cliff at a speed of 15 meter per second. Then the frequency of sound that the observer hears in the echo reflected from the cliff is, velocity of sound in air is given. This is a topic from the chapter waves. This question is from the chapter waves actually. So what you have to do, you have to use Doppler's effect in this one. So what is the formula for this one will be, you can use this one, F and then 300 divided by 300 minus 15. 300 is the velocity of the sound. So F is given to you 800 Hertz, yes, multiplied with 300 divided by 300 minus 15. So if you use this, your final answer will be 838 Hertz. That is option number 3. This is the correct answer. Number 10. A uniform rope of length L and mass M hangs vertically from a rigid support. A block of mass M2 is attached to the free end of the rope. A transverse pulse of wavelength lambda 1 is produced at the lower end of the rope. The wavelength of the pulse when it reaches the top of the rope is lambda 2. The ratio lambda 2 by lambda 1 is given by option number 2. So again you see there is a concept of mechanics as well as you can see the wavelength is also attached with the question. The right answer for this one is number 2. So you need to check how number 2 came. Just use the concept of motion and put the diagrams nicely. You will see that your answer will come. So as I told you, if you solve this one, the right answer for this one will come to be option number 2. So this one is its right answer. Now let us move to the next question, that is question number 11. A refrigerator works between 4 degrees Celsius and 30 degrees Celsius. It is required to remove 600 calories of heat every second in order to keep the temperature of the refrigerator space constant. The power required. So if you see, again this question is from thermodynamics and the topic is the reverse of heat engine, that is refrigerator, and the right answer for this option is 236.5 watt. Okay, you need to use the efficiency formula at first and then the power formula. The formula is there directly, you just have to put the formula and get the answer. So option number 3 is the correct answer, 236.5 watt. So now let us move to the next question, that is question number 12. An air column closed at one end and open at the other resonates with a tuning fork with the smallest length of the column is 50 centimeter. The next larger length of the column resonates with the same tuning fork is, okay, the first one is 3 lambda by 4, you have to use directly lambda by 4. The next one is 3 lambda by 4. Okay, now if you use 3 lambda by 4, you will see that your answer will come out to be 150 centimeter. You can try it by yourself, just use 3 lambda by 4. If you use this formula, your final answer will come out to be 150 centimeter. So now let us move to the next question, that is question number 13. Question number 13. Consider the junction diode as ideal. The value of current flowing through AB is, how much is the current flowing through AB? You have to calculate that. So this question is little knowledge you need to require. This is from the chapter semiconductor. So what you need to do is, out here you need to calculate the current flowing in the circuit. So you will need two things, resistance you have here and you need potential. So potential, how you are going to calculate? V is equals to this point VA minus VB. So it will be 4 minus of 6, that is plus 6, 10 volt. So just use V equals to IR. So I will be equals to V by R, where your V is 10, R is how much? 1 kilo ohm, that is 10 to the power 3. So 10 to the power minus 2 ampere is the correct answer. Number 2 will be your right answer. Now let us move to the next question, that is question number 14. A charge flowing through a resistance R varies with time t as q equals to at minus bt square, where a and b are some positive constants. The total heat produced in R is how much? So you need to calculate the total heat. So what is heat? Heat is equals to Vi, the change of the rate of power dissipated, or you can say heat is nothing but the power. So you have to calculate H is equals to Vi dt. You need to find out this one, right? So how you are going to do it? You need to find out I first. I will be equals to dq by dt, rate of flow of charge is current. So from here you will see the q is given to you. You can write it down as capital Q, also it's there as capital Q. So if you solve this one and then put it here, your final answer will be option number 1, a cube R divided by 6b. So this is the correct answer for option number 14. Now let us move to the next question, that is question number 15. A black body is at temperature 5760 Kelvin. The energy of radiation emitted by the black body at wavelength 250 nanometer is U1. At wavelength 500 nanometer is U2 and that of 100 nanometer is U3. Wind's constant is given to be B equals to 2.88 into 10 to the power 6 nanometer Kelvin. Which of the following is correct? Okay, we need to calculate, we need to see which one is correct out here, which will be the correct option. So first thing from this topic you need to know wavelength, how it varies with temperature. Temperature is inversely proportional to wavelength, right, and energy is directly proportional to temperature. The one which has got least wavelength will have high temperature. So if you can see U1 has got the least wavelength and its temperature is high, fine. So from the question, if you want to find out, you will see that option number 3 would be the correct answer. That means U1 is greater than U2. So option 3 is correct. Therefore, we will move to the next question. Coefficient of linear expansion of brass and steel rods are alpha 1 and alpha 2. Length of brass and steel rods are L1 and L2 respectively. If L2 minus L1 is maintained same at all temperature, which of the following relation holds very good for the answer? Okay, this is from the chapter thermal properties of matter, and you need to calculate the expansion in length, linear expansion. So you know that change in length is equals to L alpha L1 alpha 1 delta T. This is for the length L1. So change in length L2 will be equals to L2 alpha 2 delta T. So both holds good, it's same, it's maintained at same temperature. Therefore L1 alpha 1 delta T will be equal to L2 alpha 2 delta T. Delta T get cancel out. So your final answer is L1 alpha 1 is equals to L2 alpha 2. So you search in the option which one. So if you see my option and this one is same, just I have got it as L1. So option number 4 is the correct answer. So now we will move to the next question, that is question number 17. Question number 17. A NPN transistor is connected in common emitter configuration in a given amplifier. The load resistance of 800 ohm is connected in the collected circuit at a voltage drop, it is found to be 0.8 volt. If the current amplification factor beta is 0.96 and the input resistance is 192 ohm, the voltage gain and power gain of the amplifier will be respectively how much? Okay, this question you have to calculate. So what you are going to do? You are going to use the formula from the chapter semiconductor physics, that is from the part transistor. We can use this formula. First you need to calculate voltage gain. So voltage gain AV is equals to beta RC by RI or R out by R in. That is RC is given to us, RI is given to us, beta is given to us. This can be calculated. So also last but not the least, you need to calculate power, average power. It will be beta multiplied with AV. So this one will give your average power. So your final answer comes out to be option number 1, 4,3.84 if you put the values, right. So now let us move to the next question, that is question number 18. Number 18, the intensity at the maximum in a Young's double slit experiment is I naught. Distance between two slits is given to be 5 lambda, where lambda is the wavelength of the light used in the experiment. What will be the intensity in front of one of the slit on the screen placed at a distance d is equals to 10 of small d. So what you are going to do out here? This is a question from the chapter wave optics. Okay, first you will calculate the path difference. What is path difference is given in the question. Delta x will be equals to what? Dy by capital D. So dy by d is the part difference. Once you know the part difference, you need to calculate the phase difference, which is given by phi is equals to 2 pi by lambda, right? So once you know the phase difference, finally you have to use the formula I is equals to I naught cos square theta by 2. So you put the value, that is phi by 2, not theta is out here, phi by 2. So if you put it in the equation, your answer will come out to be option number 4, I naught by 2. Now let us move to the next question, that is question number 19. A uniform circular disc of radius 50 centimeter at rest is free to turn about an axis which is perpendicular to its plane and passes through its center. It is subjected to a torque which produces a constant angular acceleration of 2 radian per second square. Its net acceleration in meter per second at the end of 2 second is approximately will be how much? So options are given to you. You need to calculate its what? Acceleration in meter per second square. So this is a question from again from I can say system of rotational bodies, where a body move in a circular path and you need to calculate its acceleration. If you find or use the formula, acceleration formula, you will see that the final answer is coming out to be option number 1, that is 8 meter per second square in 2 seconds. So this is the right answer, number 1. Now let us move to the next question, that is question number 20. Question number 20. An electron of mass m and a photon have same energy E. The ratio of wavelength associated with them is, okay, this is a question from the chapter dual nature of radiation and matter, that is of class 12. So let us see how can we solve this one. I need to show you this one, that's why I am showing. Wavelength of an electron according to de Broglie is given by h divided by root over of twice m of the kinetic energy E, right? And then what else we have taken? A photon. And the wavelength of the photon can be written as h by p, and we know p is equals to E by c, where c is the velocity of light, so it can be written as hc by E, right? Just take the ratio lambda E by lambda p, it will be h divided by twice m of energy with the root over, and this one will be hc by E. So h get cancel out. So your option will be, if I take this one will be root of E, so it will be 1 by c root over of E divided by twice of m. See, so which one will be the correct answer? Let us see from the option. So if you see the option number 1 is the correct answer. Half means it's root over only, so 1 will be the right answer. Now let us move to the next question, that is question number 21. A disk and a sphere of same radius but different masses roll off on 2 inclined plane of the same altitude and length. Which one of the 2 object gets to the bottom of the plane first? You take a disk and a sphere, you will see that the sphere reaches at the bottom at first. So number 2, sphere, is the correct answer. So option number 2, I can click on this one. 2 is the correct answer.
So which one of the following characteristics is associated with adsorption? So basically this question is you can say it's come from thermodynamics as well as it's come from the surface chemistry. Okay, so now we are moving to the solution.